A very good afternoon. A very good afternoon. So nobody have joined up till now. It's okay. So someone mentioned that the font size are very small. So hence, what I will do is I will zoom it like this. Hello, Yoga. Hi. So I'm trying to zoom the thing. So I can either zoom it like this, okay, and other thing I can do in uh, YouTube video, okay, okay. I also saw my own videos. Yes, there are a lot of problem there in that sense. Hmm. So I will take like that in mind now. Okay, okay, okay. So I will start now. Yes, yes. Okay. So sir taught lot of things in upcoming time, like in the this week. So it was something regarding uh, assembly of matrices and then solving them. So to have a clear idea, I am taking the mass, so spring system. So there are three springs, no masses at all. Okay, there are just three springs with spring constant K1, K2, K3. And now at one of the nodes, at node 3, there is a force applied F, and at other point there is no force applied. The external forces are not there. So my first question will be like, if point 1, 2, 3 and 4, like out of all these four um, points, where will the forces be? So at point 1, will there be any force? Hmm. So external force is at point 3 only, but at point 1 and 4, will there be any force? Yes, it's fixed at one end. Only the force will be due to the spring, right? That spring will be giving some force, and the forces will be balanced by the reaction force by the wall, right? Oh, yes. So the only external force is force at 3. Now there are two methods to put them into a solvable form. In one, we can take as those points we can take and we can apply FBD, okay, free body diagram, and then we can solve for like we can write a matrix kind of thing, and finally we can solve. So we will try that first, and then we will look at the other method from which the finite element method is kind of part of. So first we will look at for how is different from FBD. Okay. So at point one, let's say this is point one. This is point one. The force, there will be two forces actually. So let's define कि यहाँ पर the displacement, because as the force is in this direction, all the movement of the points will be at that direction only, right? So we will say it u. Let's say we will denote by u the movement of these nodes u2, u3, and there will be one more. Let's say it's going inside the wall u4. Okay, we will put the constraint afterwards. First, we will just put what are the variables. Okay. So here the u1 at point 1, u1 is there. So u1 this is moving as u1, and the force is coming in this direction, the spring force. It will be resisting it, and what will be that force be? It will be k1 u1 minus u2. Okay. Okay. So we can write the equation as F1 is equal to K1 U1 minus U2. Now similarly at point 2, now at point 2 what is happening, like now again as it's moving in that direction, so one force will be coming from this direction as K1 U1 minus U2 only, the same force which is here now, the force which is here is again here, right? In point 2, and let me write the point names also. This is point number 1, this is point number 2. And the other side, the force will be K2 K2 U2 minus U1, no, U3. So the third like moment of third point is called term as U3. It will be like this. Okay. If you want to write the equation, F2 is equal to uh, K1 U1 minus U2, or this is in the negative direction. So K2 U2 minus U3 minus K1 U1 minus U2. So which comes out to be minus K1 U1 plus K2 plus K1 U2 minus K2 U3. Okay, so this will be for point number 2. Now for point number 3. Now point number 3 and point number 2 will be similar, like in like, there are two springs in either side. So whatever force was coming from that side will be now here, like K2 U2 U3, then U3 U4 K3. So F3 can write as K3 U3 minus U4 minus K2 U2 minus U3, and it can be written as minus K3 K2 K3, right? Minus K2 minus K2 U2 plus K2 plus K3 U3 minus K3 U4. And we know that F3 is equal to F. Okay, but we will put those values afterwards. First, we are just writing the expression out of it. And the final, we know something is coming from here, the wall, and this direction it will be there. This is point number 4, U4, and here it will be K3, U4 minus U3. So hence F4 becomes as minus K3 U3 plus K4, or not K4, K3 only, K3 U4. Okay. So these are our equations. If you want to put it into a matrix form, it will be something like this. So F1, F2, F3 and F4. This is one vector is equal to, now there will be some square matrix, and what else is there? So this U1, U2, U3 I can write like this. This here is U1, U2, U3. U3 and U4. Okay. Now we have to just fill up this square matrix. In equation number 1, which was this one, we can see that if we can convert this into 4 different parts. Now it will be helpful to write. So this is the matrix. Now taking the first equation, which is F1 is equal to K1 U1 minus K1 U2. So, and filling up the box, we see that here will be minus K1, only K1, and it will be minus K1. So F1 is equal to K1 U1 minus K1 U2. And empty boxes we can fill as 0. Now F2, which is the second equation now, this one. So F2 is equal to minus K1 U1. So here will be minus K1, and here will be K1 plus K2 and minus K2, 0. Similarly, F3 will be 0 minus K2, K2 plus K3, 0, 0, 0 minus K3 and K3. So this is the final matrix which we wanted to achieve. So what does this matrix show? That if we take 4 points, which is called as nodes, 1, 2, 3, 4, that red points, then we can write the equation of the write in this form. Okay. is U1, U2, U3 and U4. Now here we know that U1 and U4 are 0. Why? Because that is fixed. Yes? Okay. And F3 we know is equal to F. Hmm. So now we have to solve this equation where unknown are F1 and F2. So whatever is unknown, I'm coloring them. Coloring by this purple. F1 and F2 we don't know. Then F4 also we don't know. These will be F1 and F4 will be kind of a reaction forces. And U2 and U3 also we don't know. Okay. So reaction forces. Now how to solve them? So if we see in the algebraic sense, this is F1 and F. So taking the first equation as it is, where U1 is 0. So now we got our F1. So U2 is equal to F1 by K1 minus 1. So if we put in the second equation, so U1 is 0 and U2 का value is F2 is equal to K2 plus K1. U2 value is minus F1 by K1 minus K2 U3. So from here we got U3. So it should be equal to F2 divided by K2 minus में यहाँ पर check करना कि if it's right or not. So one relation we found is this, and another relation we found out is this. So we know the value of U2 and U3 in form in the term of F1 and F2. Now we will look at equation number 3. Here U2 value we can put and U3 value we can put and U4 is 0. So let's put those value. Let's see what it will end into. So U2 value was minus minus plus F1 by K1 plus K2 plus K3 U3. Now U3 value will put, and its value is F1 K1 K1 plus K2 by K2 minus F2 by K2. So this is the, and F3 we know is equal to F. So F is equal to, I'm just rewriting it. Okay. This is kind of relationship between the forces. And final equation is F4 is equal to, here what we will do is U4 is equal to 0, and U3 we can put the value from this. F4 is 0. No, F4 we have to find. This was what? This was U3 into minus K3. Into K3 minus 1, and this minus will become plus. So this is another relationship between forces. So we have used equation number 1, and then equation number 2, equation number 3, and equation number 4. But still we don't know the value of F1, F2, F3 and F4. I think we're missing something. Okay, यहाँ पर minus K3 होगा. And the question also it is like that. U4, no, not together. So one way is to solve these equations now to find the value of F1, F2, F4, where F1 and F4 will be kind of just the reaction forces, which are internal forces, and F2 will be there is no force on there, so F2 will be also 0. Sorry to I couldn't mention this. F2 is also 0 because there is no force in F2. Okay, so wherever is F2, we put them as 0. Now from this equation, now F is known. Okay, F is known. So from, let's say, equation number 1, so as you will see that f is known. So in this equation, only unknown is f1 in equation number 3. So hence we can write f1. What is the f1 from there? F1 will be f by, you can simplify it, but this will be this is everything is known in here. Now once we know f1 from equation number 3, we can put this value in equation number 4, and we can get f4 k1 पे आ जाएगा into k3. Okay, so this will be f4, which came from equation number 4. Once we get f1 and f4, uh, yes, then you can get u3 from equation number 2. So u3 we knew that was this time f1, and f1 we know. So this comes from equation number 2, and u2 also we can get. Divided by k1. So this completes our knowing of value f1. So f2 is known. So there were four variables and four equations. Okay, hence it was solvable. Previously it was not solvable because f2 was, according to me, I thought that, but at 2 you will see that there is no forces. Okay, the force is only f, and there will be some reaction forces. Uh, Brown. So there will be some reaction forces by this wall and this wall. Okay, so which is our which came out to be f1 and f4. You will see the direction sense. So f4 came out to be negative. Okay, f4 is negative, and f1 and f1 came out to be positive. So since f1 is positive, so it will be in this direction. So now just to solve three linear spring, we had to go to a lot, and we have lot of equation, and then we have lots of substitution. So what else can we do regarding this? So first of all, the formulation, like instead of element wise, oh sorry, instead of this node wise, so this is method one. So node wise we are seeing and then commenting on everything. Now there is method 2, which is element wise. Both give the same result, okay, but the thing is the ease of how to do is different, and the element wise is more important in finite element method, because as the name suggests, finite element method, okay, it's not finite node method. Okay, now element wise I will explain. So we are taking only one element. First of all, let me copy paste the figure. And let me remove the annotations which I have used. So u1, u2, u3 will be same. Okay. So now what I am doing is I am taking only one element. Okay, this is my element and it's k. It's not k1, it's k of element. Okay, and so this is I'm saying u1 and u2, but of element. So how to depict that? So just remember whatever quantities I'm writing. So for example, this is some quantity, and whatever I'm writing here is for element. Here is for node, and whatever is here is for element. Okay, so this will be like this. And this will be forces. Forces was blue color I was using. Okay, these are the forces, and forces will be also written in the same manner. F1 E, F2 E. Okay, so in element now I can write this in the form. First forces F1 E and F2 E. So this is forces. I am writing for only this element is equal to. So what is inside this? We will look at what is inside this. So this is called stiffness matrix of an element. or we can also call as a local stiffness. So it has four, here it has four quantities. One is K11, K12, K21, K22, and all this is defined for the element only. So you will see that in every uh, point this element E is there. Okay, so we can replace it by first element, second element, third element, fourth element. All right. So in our case, if we will consider first element, we will just copy paste the first element. So this was my first element, and what was happening here is we can directly write it in this form. One, one. Instead of E, I'm just writing one because this is for first element. Now, as you will see that this matrix is same as like okay, let me come to that. So first of all, we will look at the value of k. So here k is equal to k1. Where it's coming from? It's just the seeing it at respect to what. So k of point 0.1 with respect to what? Okay. So if I say I and j, so stiffness of point I with respect to point j. Okay. So if you are point 1, you will see the stiffness as k1. Let's say one direction you have chosen. Now if you are looking from point 2, it will be the negative of k1. Okay. So hence we can write this term as this. Now similarly for element 2, let me copy paste element number 2. And we're not considering force for now. This matrix. For element number 2, how can we write? Just instead of E, yeah, we have to write 2. Can you tell me what these key values will be? So what will be this? Yes, K2. Okay, this will be minus K2 because really this will be minus K2. Oh, no, K3 because this element has only one stiffness, that is K2. So that is the difference between kind of the node wise and element wise. In node wise, we had to see two springs because the node was connected to two springs. But here we are concentrating on the spring. Okay, and actually this is not a spring. This is some element of finite element method. So for why I've taken this spring is because spring is we portray everything in form of spring and masses. All right. So hence it is easier to visualize. Why? That's why I've taken this problem, and I'm giving time to it. Like I think 41 minutes is spent just to explain these because these spring mass system we know we were very familiar with it because spring in series, spring in parallel we had solved right in long before. So hence this is easier to visualize. So our matrix will become like this. Now for other two I will just directly write. Okay. So this will be 3 K3. This is number 1, number 2, and this element is 3. So here instead of 1 it will be 3, 3, 3, 3, 3, 3, 3, 3. So here U2 and U3 is not defined. Here only 1 and 2 are defined. Okay. This is point 1, 1, point 2, point 1, point 2. Because we are looking at element wise. So this one mistake I have made here. So there are only 2 points, 1 and 2. Because element wise we are seeing 1 and 2. Okay, so we have all the matrices. I will just write them down. So this was one matrix. This was another matrix. Third matrix and fourth matrix. Now what we have to do is we have to assemble it. So it's just like how to assemble it. So we know that point. This is about element number one. and this is about element number 2. Oh, sorry, element number. So spring. These are four different spring. Actually, we have only three springs, so three ही होगा, fourth नहीं होगा. Sorry, there is no K4 ना. But we know that uh, here this spring at this end is connected to this end, and this end is connected to this end. Okay, meaning this thing is same as this thing, and this thing is same as this thing. So similarly for here, this thing is same as this thing, and this thing is same as this thing. So if you wanted to make a one matrix, we call as this as U1, and these two we will name same thing U2. These two is U3, and whatever is left is U4. Right? So final matrix which will be coming is F1, F2, F3, F4. I will come to this K part, but first I will write U part again. U1, U2, U3 and U4. Now see what is happening here is this I have taken. Okay, so this is coming out like this. So this is K1 plus K2. Okay, because U2 U3 था यहाँ पर U2 U2 U3. Similarly, when I'm taking this, so at this point it's K2 plus K3. And whatever is left, we can fill up with zeros. So it came out to be same matrix as the which came out via node wise. So the first realization was about how to formulate the problem. So when we are looking at node wise, we have to see a lot of directions. As you can see that I had to take care of that directions. This from this side it's coming, from this side it's coming, and at every point I have to be cautious about the direction so that the flow doesn't go at that sense. But secondly, when I have converted into elements, not just have to see that how the elements are reacting. Okay, so instead of four, I have just written three equations because there was four nodes and three elements. So element wise, it was easier once I understood it. Okay, and the way by which we assemble the thing is something like a diagonal way. So this kind of assembly we did. Okay. So this kind of assembly where we add elements of diagonal, and so from point here to here we are satisfying the compatibility equation. Okay. Yes. This was the first thing. Second thing was how to solve them. So one way of solving is first you have to know the reaction forces. Like अगर F1 and F4, I was not knowing it. F3 was F which was given, and F2 was also given because it was 0. Okay. F1 and F4, why I couldn't find it? Because of the, this is not natural boundary condition. This we will be covering after maybe tomorrow, maybe next class. We have 10 minutes to see. So if we know F1 and F4, okay, so I'm marking it by black now. So whatever is known, I will mark by black. So if we know F1 and F4, so whole matrix will, whole this vector we will know, and this also we know. Whatever is unknown is this one, U1, U2, U3, U4. Okay, so this is unknown. So how to find via matrix? Can we do some matrix manipulation and find U1, U2, U3, U4? If we know F1 and F4, let's say this is F matrix, F vector, this is K, and this is U, which is unknown. So U can be written as K inverse F, as simple as that. So instead of whole lot of these equations which I have written here, what we can do is we can put in this form. Okay, so this is called as finding the solution of the problem. So computation part. Once we have assembly, like assembly is done, now next is finding the solution or finding of U. All right. So I have one more question like this, but since we don't have time, so what I will do is if you have any doubt, any doubt up till now, I am here. I will try to ask. Okay. Okay. So anything which you wanted to get feel of, like how? Yes. Yes. Hmm. Hmm. Yes. 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 So this is. Mhm. Yes. Here will be Q1. You are correct. Here will be Q1 and Q4, which will be the reaction pair. This will become zero only because these we don't know. Okay. Only this is known, and यहाँ पर कुछ नहीं था. Only Q1, Q2 will come here. All right. So hence it will be known. Everything will be known. So this I wanted to cover in the next class, but okay. Mm. Yes, yes. So Q is a natural boundary condition. Like what natural boundary condition is nothing but the reactions. As you have seen na, everywhere, the reactions are called as natural boundary conditions. So in cantilever beam also you have seen that. Um, have you solved any beam problem, or in future you will solve beam problem, and then you will realize it more. Okay, this Q1, Q2, Q1 and Q4 are reaction forces, so which are also known. So everything is known in the force term. Okay, everything is known in the stiffness term. Just the U we don't know. U also some part we know. Like here we know the U1 and U2, U1 and U4, you know, because of the essential boundary conditions. These are called essential boundary conditions. Okay. So this U1 and U2, U4 are essential boundary conditions in this problem. And Q1 and Q4 are called natural boundary conditions. Okay. Yes, nice observation. Anything else? Okay. So, okay, we can look at some small problems like which are asked in quiz. So in quiz, this kind of question will be asked, such as if that blue line, no, blue line, if it's an element and red are nodes, and can we write like this? F1 is kind of our force on one. One means node. Okay, these are nodes, and this is for elements. So which one is correct? So something like this will be asked. Okay. So for example, here we can write this F1 is equal to F of 1 1. F2 is equal to F21 plus F12. Okay, these are like blue terms. Similarly, F3 will be F22 F13. Like 3 ka first one and second ka 2. Okay. F4 will have F of 3 ka, oh sorry, 3 ka second element or second node. Okay. So in this, it's clearly like 1A is wrong, this is wrong, and this is the right answer, not true. Okay, others are okay. Okay, so this kind of problem. Then which of the following is not true? The size of global force vector is 4 into 1. So this is the same problem as the previous one. Okay, three springs are there. So size of global force vector was 4 into 1, right? F1, F2, F3, F4. You know. The second is size of global stiffness matrix. Stiffness matrix was 4 into 4. Here is given 8 into 8. So this is false. Now size of global primary variable was 4 into 1. So U1, U2. That is also 4 into 1. The size of local stiffness matrix 2 into 2. That is also correct. So this is the correct. Now there is some question where it's like primary variable converges faster, slower, or the same rate. I don't know why none of these is here, but or we cannot judge. That's why none of the above. The primary variables were U1, U2, U3, U4. What are secondary variables are the forces. Forces in this sense, but it could be slope and other, like whatever is not primary, na? Those are termed as secondary variables. So it is, we can prove that primary variable converges faster because we are finding U1, U2, U3. Okay, we are not finding F1, F2, F3. If it's in the equation only, then it becomes. Are you getting it? Okay, so here that question came because which you asked now. Consider the global finite element equation Ku is equal to F plus Q. So that Q matrix will come because of the natural boundary condition. Okay, so Q is the answer here. Then in this question is asked like what Fe denotes. Okay. So Fe is nothing but the external force which is applied. So here Q is the external force. Now in the condensed form of the assembly level equation, after implementing the boundary condition, the system can be represented as K U F plus Q. In our equation, which term is unknown? The U. Hmm. Okay, so uh, you can WhatsApp me if you have any doubt, okay, regarding this, wherever you are. Okay. Chalo, if you don't have any problem, then let's meet next week then. Okay, bye. Hmm. Recording.